All right, guys, let's focus in. Focus in. So, we finished chapter 7. Yeah, it's printed kind of small. New chapter. New chapter. All right, guys, focus in. Focus in. So, what we're starting today is chapter 6, which is going to be over exponential and logarithmic functions. We're going to cover 6.1, 6.2, 6.3 this week. Next week, we're going to go, well, Monday, we're going to go back over that test. Yes. Yep. Front drawer. I'm going to go, so, focus up here. Guys, up here. Focus up here. So, we're going to go back over the chapter 7 test on Monday because I know some of y'all did well on it and some of y'all did not do as well as you could have. Because I think some of it might be just the snow because the amount of days we miss and things broken up. But I also think some of it is just when we were struggling or when you did not understand something, again, asking questions is going to be key, or especially when you're doing the assignments. I'm not expecting y'all, again, if you have time to do them that night, do them that night. Get them knocked out, get them done. Because if there are questions, and the homework is really to help y'all get practice on your own, so if questions do come up, y'all can ask them, and we can address them as we go. And I've said this before, I'll say it again. Again, email me. You are not going to bother me. Email me whenever. If you have a question, email me, especially take a picture of it, send it to me. I will get back with you pretty quickly. I think most of y'all that emailed me, I do get back in pretty quick fashion. So again, because part of the reason I want to go back over it Monday is for y'all to see that, yes, y'all all can do this and do very well on it. And some of it might be one or two little things here and there, but for the most part, again, asking questions and engaging in this. Now, the lesson today, we'll have an assignment with it. We're going to finish this part in one day, and I will be very surprised if y'all actually take the assignment home. Because exponential and logarithmic functions, the first thing we're going to talk about is exponential growth and exponential decay. Exponential growth and exponential decay. A function is considered exponential growth where we have f of x equals b to the x and b is greater than 1. Because if b is 1, it doesn't mean a whole lot for us. Because all we're saying is that we have the function 1 to the x, 1 to the x power. It's a straight line because no matter what power we put 1 to, it's just going to be 1. So it doesn't do anything. So b has to be greater than 1. If b is greater than 1, it's going to be considered an exponential growth. So the classic case is 2. Let's just say 6. 6 to the x. So we have this function, this graph here. And if we look at this here, 6 to the 0 power is 1. 6 to the first is 6. 6 squared is 36. 6 to the 7th is 279,936. And by the time we get to 6 to the 8th power, this becomes such a big number, it can't fit in that spot. So that's why they call these exponential growth, because the amount that it's changing, the amount the y value is changing from one x to the next is getting bigger and bigger. So we call it exponential growth because it's growing exponentially. The other one we have is exponential decay. Exponential decay is going to have a value b between 0 and 1. Questions on this so far? And as we see here, it's going to be shrinking. All right, let's look at these first 4 examples. So the first one here, we're going to do 2 parts. Y equals 2 to the x. All right, focus in. The base for this is what? 2. So is that greater than 1 or between 0 and 1? So this would be a growth. Because if the base is greater than 1, it's exponential growth. It's growth. If it's between 0 and 1, it is decay. And yes, in some senses, decay as in right away is true. So that actually is true. It does connect to that in some. Because if you talk about radium or kind of radioactive elements and their half-life, it is actually a decay function. Because I think y'all have also heard of carbon dating, where we can carbon date fossils or stuff. Again, we're talking about half-life, this exponential decay. All right, guys. So now it also asks for us to evaluate when x is 2. All that means is that we're going to replace x, the exponent, with 2. So 2 to the second power is 4. So we can evaluate it for any number we want. We could say -3, 7, -24. We're just evaluating it for a number. Questions on A? Let's look at B. 1/2 would be decay because our base here of 1/2 is between 0 and 1. This would be decay. Now this one here did ask us to evaluate when x is 2. So we can just replace the x and the exponent with 2. So we have 1/2 to the second power. And 1/2 to the second power is 1/4. Questions on these so far? Let's look at the next one. Growth, 1.3. Is it greater than 1 or between 0 and 1? Now we need to evaluate. So we want to evaluate this when x is 2. So we have 1.3 squared. Questions on this here? Let's look at B. Y equals 1/3 to the x would be decay. Because 1/3 is between 0 and 1. It's not greater than 1. And then we're going to evaluate this when x is 2. So 1/3 to the second power would be 1/9. And these evaluating, we can just plug into the calculator. The calculator will do that for us.
So 1/9 an answer to?
Yeah. Yeah, so the 1/9, yes, because that's just the part where and evaluate for when x is 2. So we're just evaluating for a given value. All right, guys, focus up here. Let's look at these next 4. So these here, they just want us to say if it's growth or decay. So 4 to the x, 4 is greater than 1, so it would be growth. Number 2, y equals 2/3 to the x would be decay because the base is between 0 and 1. Number 3, 0.25x. Yep, would be decay. And the last one would be growth. Questions on this so far?
What is that? That looks scary.
Are you ready for the next part? The natural base e is an irrational number. E is in the same place as pi. E and pi are both irrational numbers. E is helpful for us in logarithms, our natural logarithms. It's going to become helpful. But E is just a number. E is just another way to represent this number here. Now, if we're calculating or finding it, we use the 1 plus 1 over x to the x. All right, guys, focus up here. But one of the interesting things with E is that there's a lot of properties where we can treat it almost like a variable. So, up here. E to the third times e to the sixth. If we multiply like bases, we add the exponents. So this would be e to the 9. Yep. All right, guys. Yeah, because we multiply like bases, we add the exponents. Yes. So B, we can do the number first because we're dividing. 16 over 4. 16 divided by 4 is 4. When we divide like bases, we subtract the exponents. So 1. And since it was bigger on top, it stays on top. Questions on A or B? Now C, 3e to the negative 4x squared. Powers of powers multiply. So 2 ways we can think of this. One, since we're squaring it, we're saying that we're multiplying it by its self. So really all we're saying is that we're taking 3e to the negative 4x and multiplying it by 3e to the negative 4x. Single term, so we can just multiply it by itself. So we'll multiply the numbers first. 3 times 3 is 9. E to the negative 4x times e to the negative 4x. When we multiply like bases, we add the exponents. So negative 4x plus negative 4x. Negative 4 plus negative 4 is negative 8. Negative 4 plus negative 4, negative 4 minus 4 would be negative 8. Negative 4 plus 4 would be 0. Questions on A, B, C? Are you ready to look at D? Now, D, properties of radicals, one of the properties is that we can split a radical, because if what's inside is being multiplied, we can split it apart. Because as long as the radicals are the same, we can split them apart. We can also put them back together with multiplication. If it had been 16 plus e to the 4x, we can't just split it. Because our property with multiplication, the square root of a times n, is the same as the square root of a times the square root of n. If what's inside is being multiplied, we can split it apart. Now, why this is helpful is because, well, we can start off with the square root of 16 is 4. Now we need to find out how to take the square root of e to the 4x. Now we'll dig into this more, especially in our radicals chapter. This here, the nth root of a to the x. because we haven't gotten to this yet, but this can be rewritten as a to the x over n. The nth root of a to the x is the same as a to the x over n. Now, this we've talked about or has been talked about before. But if we said we don't normally write the 2, but the square root of 4 squared is what? 4. Because the square root and square would cancel. And we're used to seeing that. The square root and square canceling, square root and square canceling. And for the most part, especially in middle school, we just said they crossed out and moved on. Yes? If we look at this here, a, in our case, is 4. The x is the number inside our radical, our power, which is 2. The number on bottom is the index. So really, when we take the square root of 4 squared, it's the same as saying 4 to the 2 halves power. Those are the same statement. But what is 2 divided by 2? This is why the square root of 4 squared is 4, because of these fractional exponents. So if we look at this here, e, the square root of e to the 4x, really what we're saying is that we have e, the index number that we're taking on bottom is 2 because it's a square root. The number on top would be the power, which is 4x. 4 e, 4x divided by 2 is x. Really, we're just taking that exponent and dividing it by the index. Questions on this here? All right. Let's look at number 1 here. E to the 7th times e to the 4th. Since like base we add the exponent, 7 plus 4 is 11. 24 e to the 8th divided by 8 e to the 5th. 24 divided by 8 is 3. E to the 8th divided by e to the 5th is e to the 3rd. And that's it. Questions on 1 and 2? So 10e to the negative 3x to the 3rd. So really what we're saying is that we're taking 10e to negative 3x and multiplying it by itself 3 times. So let's start off with our numbers. 10 times 10 is, times it one more time, we get 1,000. 10 times 10 is 100. 100 times 10 is 1,000. All right. Now the e to the negative 3x times e to the negative 3x times e to the negative 3x. When we multiply like bases, we add the exponents. So when we multiply like bases, we add the exponent. So negative 3 plus negative 3 plus negative 3. Yep. All right, guys. Focus in here.
Anyways.
All right, guys. So, now one of the other things with this, whenever we have this single term to a power, powers of powers multiply. 10 is to the first power. So our 1 times 3. One more time. There we go. Would be 10 to the third. Now our e to the negative 3x to the third. Powers of powers multiply. What is negative 3 times 3? Powers of powers multiply. Because we're saying we're multiplying it by itself 3 times, so we have 3 groups. 10 to the third is...
Wait, are you showing us like a faster way of doing this?
Yeah. So it gets us to the same spot. Now this works. Guys, focus up here. Focus, focus, focus. As long as 10 and e are being multiplied. As long as it's a single term, we don't have addition or subtraction. If it's multiple, 10 plus e, we have to actually multiply it out. We have to distribute. We're not going to see that here. The cubed root of 64e to the 9x. We're really looking at 2 things. We're looking at the cubed root of 64 and our cubed root of e to the 9x. Now, cubed root of 64 is 4. Because we're looking for what times itself 3 times is 64, and that's 4. Now, to see how the e simplifies, we can change it from a radical to a fractional exponent. Now, the 9x, what's inside is going to go on top, and our root, the index, is going to go on bottom. So we're saying 9x over 3. So what is 9x divided by 3? 3x. So we're saying the cubed root of 64e to the 9x is 4e to the 3x. Questions on this here? We ready for the next part? Now the natural base, the natural log, or this natural base function can be considered exponential growth or exponential decay. It is considered exponential growth if the exponent is positive. Because when the exponent with e is positive, it's going to be growth. If the exponent is negative, it's going to be decay. And the reason that it's going to be decay with a negative exponent is that our y equals e to the negative x. Well, to make that exponent positive, it'd be really putting it into the bottom of the fraction, so it's going to be between 0 and 1. So we don't have to do that. We just have to look at the exponent. If the exponent's positive, it's growth. If the exponent's negative, it's decay. So if we look at the first one here, 3e to the x. The exponent is what? Positive or negative? Positive, so it is growth. B, e to the negative 0.5x. Is the exponent positive or negative? Negative, so it is decay. Number 4, 1/2 e to the x. It's positive exponent, so it is, because when we have e, we're focused on the exponent being positive or negative. Since it's positive exponent, it will be growth. Number 5, 4e to the negative x. It's negative exponent, so it would be decay. And lastly, 2e to the 2x is growth. Questions on this here?